Welcome to Cassandra Lunch number 38. Today we're going to be covering how to use Cassandra's SSTable, the raw files in Spark. A lot of cool things we can do with that, but basically this driver for Spark to read SSTables got released last year, and OB is going to be talking about it. This job that I have right here, I could use some help. We used to have Akwi help a lot as a co-organizer, but if you'd like to be a co-organizer, help get speakers, would love to be able to get you involved. It's really not that hard. Takes a little bit of time reaching out to folks in the Cassandra community around now, really around the world. Anybody can come. Right before we were just in person, but I would love to have you. We are part of a larger community called Data Community DC, and Data Community DC is actually made up of a lot of different groups, generally around data, as you can imagine. We also call ourselves DC2. What do we cover here? We cover things related to Cassandra protocol. Cassandra has generally a couple of different protocols. It's how the nodes talk together. It's how the clients talk to the node. Well, many different systems either implement both of those in some way, or at least the client part. So, hopefully we'll cover things like Skilla, Yugabyte, Cosmos, Amazon Key Spaces. There may be another one out there. I don't know. But the point is that we're really fascinated with Cassandra and the ecosystem around Cassandra as well. So Spark, Kafka, how it works with Cassandra. There's other technology like Flink. We'll be able to cover that in the future as well. Normally at this time now, almost for a year since we've been in COVID lockdown, we just ask if there's anybody new that would like to just say hi, what brought them here, and then what they hope to get out of it. A lot of folks here are returning. So Daniel, do you want to quickly say hi? You don't have to. You can just say hi in the chat if you'd like.
Hello. Hi, everyone.
Hey. Well, there's Danielle, but then there's also Daniel.
Oh, apologies.
Yeah,
No problem.
All right. Hey. Let's see. Group rules. If you have a question, just ask it. Be polite, and use that as an opportunity to add to what the person is sharing. At least some speakers they would like you to keep the comments until the very end, but you can always just in the chat ask questions as they come up. Our company, Anant, we work on technologies related to global, real-time, and data, and those are generally Spark, Cassandra, and Kafka. So this is part of our daily life. DataStax is a partner and a sponsor. GW University has been a great supporter of Data Community DC. So we also have some local sponsors and some institutional sponsors in the DC area. Anybody have any announcements for jobs, meaning they're looking for a job, they're hiring somebody, upcoming events? Well, we are going to be doing a workshop with DataStax in a few weeks. I have to double check the dates. Basically, how to migrate to the cloud from on-premise, and what are the options out there with Cassandra. And I think it's going to be two parts. One is just the general architecture and a little bit more of the tactical details in the second one. We'll see. Upcoming topics, I think in the backlog, we have some folks that are going to be presenting on Jenkins and Cassandra, how to use it, Airflow and Cassandra. Maybe I think even data catalogs, which ones support it, which ones don't. All of our videos are online, at least starting from Cassandra Lunch 10, I believe. And then we also want to highlight Cassandra.Link. It's a manually curated site with about roughly, I think, well over 1,000 links related to Cassandra or anything, well, anything related to Cassandra, but also Cassandra, Kafka, Cassandra Spark. You can imagine all the different combinations and permutations. And you can sign up for the newsletter so you can get updates on, I think, on a bi-weekly basis. And with that, I will hand it over to our speaker, Obi. Obi is a junior engineer at Anant, and is fascinated with data science and machine learning. And so I'm really excited to hear what he has to say. All right, Obi, up. Now it's you. I think you're double muted, Obi.
Okay, how about now?
Yes, we can hear you.
I can never remember which sound stands for mic off and which one stands for mic on. But anyway, as you heard, I'm Obi. I'm a junior architect at Anant, and I love data science. But what we're going to talk about today is, as you heard in the intro, projects that combine the use of Cassandra's SSTables and Spark. And there are a couple, but generally they will fall into one of two categories, which is read SSTables or write SSTables. And the way that we're going to do that, because I was not able to get the project running for a demo today, which means that we're going to have a more general conversation. We're going to talk about Cassandra and SSTables, and then we're going to talk about those particular projects. And the consequence of not having a demo, because I usually like to keep questions in the chat to like go through in between the actual presentation and demo. Today, at least, if you at any point have a question, you can just speak up or put it in chat, and we'll get to it whenever. Okay, so starting off, what is an SSTable? So SSTables are immutable on-disk storage for your Cassandra cluster. So when data comes in, it will be logged to the commit log, put into memtable, and then eventually, in its case, based on schedule, based on load, or when triggered by a user, that data gets flushed out to SSTables and written to disk, where it is no longer changeable. And then there's a process called compaction that happens in Cassandra clusters where multiple SSTables, because your memtable keeps filling up, and you don't change old SSTables. So if a change comes into data that's already there, you just put it in a newer SSTable. And when compaction happens, it combines all your different SSTables and deletes old versions of your data. And an SSTable actually consists of a number of different files. So data.db actually holds the data. It's like in an encrypted JSON format, because Cassandra underneath the hood is a sort of key value store. Index.db, which really tells you where in data.db certain partition keys actually are. Summary.db, I'm not actually sure what that's for. It holds some of the data from index.db. I guess it's for placing yourself properly in index.db. So you find the correct location in summary.db, which greatly narrows down your potential locations in index.db.
Yeah, it's generally stored. It's an in-memory sampling, right? But it's generally in memory, but it's stored on disk for kind of like resiliency.
Okay.
It's kind of the same approximate location of where it is, right? So a short scan and then it tells you it's in this area over here.
Yeah. Right. So you don't end up scanning the entire index.db.
Yep.
You look in summary.db and you look in a subsection of index.db. Filter.db is a Bloom filter, which helps you figure out whether your data is actually there or not. Impression info, statistics, which is the extra like Cassandra data, including tombstones, time to live, that sort of stuff. Error checking code. Yeah. So this is a sort of visual summary of how you get data. You look data from your SS table, you look in index summary, and that points to specific rows in the SS table where you can get your data from. All right, so in the Cassandra read sequence, SS tables is where you get your data from if there's the most up-to-date version is not currently in the mem table. And you have to check a bunch of those component files to make sure it is, and to go to the correct location to actually get that data out. But you pull that data from the SS table file. And then Cassandra writes, the commit log will log any changes in order, in like chronological sequence. Mem table is in memory. And then mem table and SS tables are both per table, whereas commit log is for the cluster as a whole. And then data that's in mem tables gets flushed to SS tables eventually. And then during compaction, you might have your data split between a number of SS tables for a single table, and you might have updated rows, which are in some SS tables with different timestamps and not others. And then as SS tables accumulate over time, your compaction triggers, combines your SS tables into a single SS table, deleting any replicas and tombstones and like expired data, that sort of stuff. Okay, so the actual meat of today's presentation, Spark projects that interact with SS tables. So the first type is your SS table reader. So I think there is like a DataStax SS table loader or something like that, but that loads data that's in SS tables into a new Cassandra cluster. Whereas
By the
this
way,
is all about.
That's part of Cassandra. It's not that SS table loader is not DataStax specific. It's generally available in all Cassandra distributions. Yeah.
Okay, cool. So this project takes Cassandra SS tables and loads them into Spark as a data frame or an RDD. So it's actually potentially being added to the base Cassandra code. I found this log of it, where people who maintain Cassandra were talking with the creator of the project, which is on GitHub here. So basically what this does is it reads raw SS tables into Cassandra, and apparently it can do it even from snapshots. So it doesn't have to, we talked about snapshots briefly in the backup restore, like Cassandra Lunch, which was, I couldn't tell you the number, but it's up on the blog and the YouTube channel. But essentially it's taking a snapshot of your cluster, and you can access those SS tables without going through your Cassandra like read process. And even if you're accessing SS tables that are actually on the Cassandra cluster, you can do it without touching your normal Cassandra read process, which means that if you have a cluster that is performing at scale with a bunch of reads and writes already coming in, you don't want to put more load on top of that, but you still want to get your data into Spark, you might use something like this. So it uses a bunch of the base Cassandra Java classes in order to do some like compaction processing while it's reading from your SS tables. And it has a feature where it can split up a read job to distribute it to a bunch of different Spark workers so that each worker goes and reads the SS table on a particular replica. So you can perform reads using this tool with a given consistency level. So the way normal Cassandra reads work, they have a consistency level that all the results from the replicas need to agree to before giving you back your data. And you can replicate that process with just the SS tables and your Spark workers, so that you can maintain your consistency level without putting extra load on the Cassandra cluster. So the proof that they showed it to the Cassandra maintainers was that they used it to export a 32 terabyte Cassandra table to HDFS in Parquet format very quickly. It says a 20 times improvement on previous solutions. And we can also go look at some of how this works. Well, maybe save that for later if we want to actually go through the code. But the other type of Spark SS table sort of interaction is your bulk Cassandra writer. So the last one is used to read SS tables to get data out of Cassandra in bulk without going through the Cassandra read process and putting more load on the cluster. And this is sort of the opposite. What you're doing is you have your data in Spark already, and it matches up with some Cassandra table, but you want to write it to your Cassandra cluster without triggering the Cassandra write process and putting more load on your cluster. So it writes data from Spark in SS table formats directly to a Cassandra cluster. And just like the last one, it uses your internal Cassandra Java classes, because Cassandra is written in Java, and it also uses some functionality from the Spark Cassandra connector, which I don't know if we talked about it on Cassandra Lunch, but it has a lot of features, like a token aware policy. So the connector will know what nodes data is supposed to be written from. And this tool takes some of that same functionality to split up whatever data you're writing to make sure the SS tables go to the correct places.
So it's not talking to, well, what I'm trying to understand is that it basically, it reads, it has a data frame, for example, right? So you have data in Spark somewhere. Mm-hmm. Why wouldn't you just say, save this as Cassandra table and let the Spark Cassandra connector deal with it? What is this bringing to the table? Is it just generating SS tables? Well, it's not, because that's the other thing, right? Sorry, it's the, no, it is writing to SS tables. But like, where does the partitioner come in? Does it actually literally go to a different server and write it, or does it do it in different directories? How does that, how does it know to be quote partition aware if it's going to SS tables? Is it, or maybe it's streaming SS tables directly to the Cassandra nodes?
Well, I think, yes, that's supposed to be what's happening. It's taking your data that's in Spark, making SS tables out of them and sending them directly to the Cassandra cluster. So in the same way that the last project bypasses the Cassandra read process, this one bypasses the Cassandra write process.
Brilliant. Yeah, that is cool. That is cool. Got it. So basically, to do bulk migration with Spark to Cassandra, like you could get data from anywhere, have it in a data frame, and then dump it to Cassandra super fast.
Yes.
Sweet. Wow, that's cool. Is this actively maintained, this project?
I don't know. I've seen, this is just a blog post on like an implementation. They have a bunch of code snippets that use Cassandra classes to do this same sort of thing. Mm-hmm. But there's also Spark 2 Cassandra, which is the one that's integrated with the Spark Cassandra connector.
Mm-hmm. Yeah, unfortunately, it's not maintained But if it's leveraging Cassandra connector and if it's leveraging Cassandra native libraries, then as long as you build it with the right dependencies, the underlying code that kind of wires these two things together should be basically the same. All right, I'm going to put that on my someday maybe pile. Cool, very cool.
All right. So yeah, like I said, there's no demo for today. I spent a bunch of time trying to get this project working, the Cassandra bulk reader, but I kept running into issues with the Cassandra classes and file utils in Java. And effectively, I'm having trouble making it work. And while the people that maintain Cassandra would requested the developer to write up like examples and blog posts about how to use it, I haven't been able to find those if they exist, and have not been able to actually get in contact with the developer.
Gotcha. Yeah, I contribute to the Cassandra blog, and no, there's no blog post on it yet.
Okay.
I would know. Yeah. Okay.
So potentially sometime in the future, because if we can be the first ones to put out a good tutorial on how to use this,
that's great.
I think that would be cool. But
hey, you get that together. We'll put it on the Apache Cassandra blog. So that's cool. Yeah, I think the SS table method is, I think it's abused sometimes, but it's also like a great secret weapon in scenarios where you have to do like a ton of information moving. Like I know there's one client that I worked with. They have several multi-hundred node clusters. So like a total of like 700 nodes across, I think, 3 or 4 clusters, and they needed to do analytics on the data. Now, normally I would say, oh, well, just make another data center, copy all the data there. And they're like, well, we do have 2 data centers and they're used for regional traffic, right? So East Coast, West Coast, whatever. So they're like, great, make another data center. And it's like, yeah, but we need to have the data then replicated a 3rd time. And, there's a high cost of hardware for that, let alone, it adds to, it technically shouldn't add anything to the read traffic, but on the write traffic, if they're doing local quorum, I don't think they have global quorum, but they were doing some serial consistency writes, and then they would have to go to every data center. And so that was kind of out of the question. Well, I don't think it's out of the question. They thought it was out of the question. So they ended up having a process that took the snapshots of the Cassandra SSTables, right? And put them on, let's say, S3, because they were on Amazon. And then they use Elastic MapReduce to basically, oh, no. I apologize. They had data in Hadoop, like HDFS, that was getting accumulated from a variety of different systems, same client. But what they wanted to do was to bring together that data into another Cassandra cluster. So they would take snapshots from their primary kind of transactional Cassandra cluster. They would bring it up in another environment, and then they would take Hadoop data, generate SSTables using the SSTable writer, and then move those into the Cassandra cluster. I thought it was a little overkill, but for them dealing with like petabytes of data, close to petabytes of data on a daily basis, it was the fastest way for them to do a massive bulk operation. So basically they would have Spark, Elastic MapReduce would grow really, really large cluster, do this operation and then go away. And you know how people are, there's nothing more permanent than a temporary solution. So this thing just kept getting used and kept getting used, But until I see this Spark Cassandra bulk reader, I've just kind of like written it off. So, maybe if this works, it's worth a try. So very cool.
Yeah.
Has anybody done any SSTable reads or writes with code? I'm just curious, other than like looking at Cassandra code. Very few people, I think, actually do it. But great, good presentation, good exploration. Yeah, I was kind of hopeful that we would have a working demo, but such as the case with open source technology, the first version, I would say even with commercial technology, the first version basically sucks. So this was their first attempt. I'm not going to give them too much flack for it. Hopefully by the second iteration, it is useful. So good presentation. Any questions from the audience, or just kind of exploratory talk about this, or any other topic of related to Cassandra?
Obi, just question one is, when we say SSTable, is it like you are directly accessing the file, or you are accessing the tables, key space and the table?
Well, SSTables are generated on a per table basis. So each table in a Cassandra cluster will have its own mem table and its own set of SSTable like files.
Yeah, he's talking about the files, JB, the actual files.
Actual files, reading actual files and getting the data. Okay.
Yeah.
Yeah, on the hard drive. Yeah, exactly.
Okay. Okay.
Yeah. Any other questions or any other topic of discussion people want to bring up? This is a Cassandra meetup, so if you have something related to Cassandra, it doesn't really matter if it's related to the presenter's topic here. Oh yeah.
Hey Rahul, this is Sunny. I just
Hey.
have one question.
Sure.
So with the AWS key space becoming popular and it's no longer in preview mode now, I guess it's fully functional on AWS.
Yep.
How is it feasible to migrate the traditional Cassandra clusters, from the EC2 instances to the managed Cassandra or AWS key space? I do know for a fact that the TTL is not supported for AWS key space, which is very much a benefit we have for the traditional Cassandra. But in terms of if client wants to migrate from the on-premises to the AWS key space, then what are your thoughts on that?
Sure. That's a great question. So they released key spaces like in the December of 2019, right? So almost a little bit over a year ago. And so there's a reason why key spaces doesn't have certain features, because key spaces is the client protocol on top of DynamoDB. In fact, they kind of talked about it in the early days of this release. There was a kind of a conversation online about what is this stuff really? Is it actually Cassandra, or is it? So it's basically DynamoDB with the client protocol on top of it. So what that means is any type of bulk migration, you're going to be limited to leveraging the client protocol. Now, that could mean, and I have not tested it, but that could mean leveraging the Spark connector. The Spark Cassandra connector works with anything that generally has the Cassandra protocol, the client protocol, right? Theoretically. So it works with Cosmos DB. It works with ScyllaDB. It works with Cassandra, obviously. It works with DataStax because they made it. I think it also works with Yogabyte. With Amazon Key Spaces, I'm not sure if it does, because basically the Spark Cassandra connector is token aware, right? It understands the ranges of data, or at least it understands the ranges of the tokens, so that it can do a scan. It can say this token range, this token range, this token range, go to this node, get the data, right? Do some filter. So Cassandra Key Spaces is not exposing. It's not exposing that that interface. It's not telling you where the tokens are. So I doubt you can use even the Cassandra Spark connector. However, if it's high availability, which it says it is, then it's possible to write a key spaces. I don't know, maybe there is a key spaces connector for Spark. Maybe I'm not surprised these days. You could just look for something on Google and it's there. So yeah, I don't think there is. So, but they do have, you know, a conversation about this on the DataStax community. But yeah, actually, what I was just saying, in fact, let me share my screen. This is exactly what I was afraid of, right? So somebody tried doing this, right? And essentially, literally, this is what happened, right? The default partitioner doesn't work on there because they don't expose the nodes. You don't really know anything about the AWS partitioners, right? So, okay, let's say you still have to do it. I would say you can use Spark to read from Cassandra and write it to using the Cassandra driver, basically, right? You can just hit the key spaces cluster as fast as possible. You can parallelize tasks in Spark, and in the parallelized task, you can say use CQL using the Java driver. And what happens then is that the Java driver is normally, if it's talking to a Cassandra cluster, it will recognize the partition and it will go to the right node. In this case, it doesn't know the partition, but the Java driver is a generic Java driver. It just needs to have a Cassandra endpoint. And when it talks to the Cassandra endpoint, it may as well only get, quote, one host that it's talking to. But for your intents and purposes, that host, that endpoint that they're giving to you is of infinite scale. So it doesn't really matter, right? You can have a billion connections to Cassandra, or sorry, to key spaces being sent via a Spark, a parallelized Spark process, and it should work. So technically, any scale task should work on key spaces because they're going to scale to your size needs, right? Speed and size needs. Does that make sense?
Yeah, that makes sense.
That's that's kind of the easiest raw method, Sunny. I would say the other more elegant method would be, take the data from Cassandra, or like have your whole architecture such that it's, CQRS. You have an event-driven system, and so you have processors, right? So you move the data over to key spaces, but then your transactional system is processing data once into Cassandra, but at the same time into key spaces, and then you can do a blue-green test, and then you can switch over. That's the best practice for like an elegant, no downtime possible type of scenario.
Right, and like this AWS key space is serverless, so we have the traditional clusters where a lot of things are there as a DBA is in our control, but since the serverless architecture, just like DynamoDB, AWS key spaces, I believe they have a replication factor of default of 3, and it has to be within the same AWS region.
Yep.
If I'm correct, but more or so, I had doubt about the TTL, because most of the customers they have the TTL logic from the application side, right?
Right.
So
right.
does it require a code change from the application perspective? Or
yeah, I mean, there's any feature that's not implemented on the AWS server side, right? It won't work. It may give you an error. You can try it, but it won't work. The other alternative that you have to go serverless, it could be Kubernetes, right? Cassandra on Kubernetes, where it's still technically Cassandra, but it's serverless in the sense that, I haven't, I don't know if anybody's tried like Cassandra Kubernetes on Fargate, but it's something to take a look at. And then another alternative, again, if you really need all of the Cassandra bells and whistles, well, with that, you have to manage it. But there is also, so DataStax Astra is they have a general Kubernetized. Astra is basically Cassandra and Kubernetes, right? It's exposed and you can try it out. But I know they're about to release a serverless Astra, which is basically to compete with key spaces and Cosmos DB. But it's Cassandra, right? Technically, under the hood, it might be something different because they have to scale infinitely. But those are alternatives if you still need the Cassandra protocol. The easiest, if you were to really compare at like the ease, it would be basically you're pitting Cosmos DB on the on the Azure side, Keyspaces on the AWS side, but then Astra, it can work on both because you can say I want my cluster on AWS or I want my cluster on Azure. But eventually you have to make the judgment call of like, cost and well, total cost of ownership, right? So those things are worth looking into.
Right. I second your thought. Yeah. And also with AWS pushing AWS key space, and promoting it, many customers, I believe, are moving, in fact, from the traditional scope of Cassandra administration to the key spaces. So my question is that what do you see the role of traditional Cassandra administrators shifting? Because on premises, they have a lot of things in their control: backup, restoration, administration, with respect to the infrastructure, the infra related things. But with the servers architecture, how has the role changed, or what would be the role if it is implemented for like AWS key spaces in terms of the Cassandra administration is concerned?
Sure. Well, people can say many people are moving, but there are 3 people that are moving. So until I see numbers, I'm very skeptical. In fact, there were 2 companies that were in the original press release for Amazon key spaces that said that they will use it. And I know both of those companies because I work with them. Okay. You can go look at the original press release and they're still not using it. Right. So I generally, when I hear something like, oh, many people are using it, I'm like, okay, let me go see the Google trends on this. Right. But in general, to answer the substance of your question, I would say I would get to what happens in a world when the Cassandra protocol is easy to just use via these serverless systems. And when I say these serverless systems, it's Cosmos, Keyspaces, Astra, Yugabyte Cloud, Skilla Cloud, right? Technically, those are all kind of cloud, or Ivan Cloud or Instacluster Cloud. It's the same general question. Do you build it or do you buy it? And if you are building it, you're building it for a very, very good reason. So, for example, we work with some global banks, right? We work with some insurance companies, and there's no way that they're going to put something onto Keyspaces or Cosmos unless they are fully on that bandwagon, and some people are. And so what ends up happening is, even then, there are some situations where I see Cassandra versus, let's say, Azure Cosmos DB, or Cassandra versus Keyspaces, and there's a cost component to it, right? So the cost of hardware, it's 0 or nothing when you're using a flexible serverless system. But there is a tipping point where that cost is more than the cost of maintaining your own virtual machines. And that intersection is the point where the CIO or the CTO may say, okay, that's great, but we're going to do our own Cassandra because it's cheaper to have 5, 10 people on staff to manage it versus spending, the certain amount of money, because Cosmos is like very expensive. What happens is, like, huge companies that have massive amounts of data, or like not as much data, but a lot of traffic, they'll go to Cosmos, they'll go to Dynamo, or they'll go to Keyspaces. And these massive companies don't understand that when they get hit with a lot of traffic, the way that Dynamo scales is that it takes the lowest common denominator and scales everything, right? So there's no selective scaling. And so when they hit that, if they can afford it, they pay the bill. If they can't afford it, they go back to open source Cassandra, or they end up using DataStax. So the role of the administrator, if they go to a buy it approach, Cosmos, Keyspaces, Instacluster, Ivan, Astra, is that it's no longer managing the DevOps, but it's to manage the data operations. It's the stuff about import, export, the question that you started with, right? How do we get data in? How do we get data out? It's the data model design. If you have a bad data model in key spaces, right, it's a hot partition. And there's still various partitions except for that hot partition. If you hit a lot of traffic, the cluster will scale abnormally and it will become very expensive. So the data administrator has to basically help diagnose that issue. So yeah, data operations for sure, right? Like the person has to be good at data operations, data in, data out, data modeling, and then diagnosing issues between the client and the server. Luckily, by the way, I hate DevOps in the sense that Cassandra DevOps is hard. Okay, Terraform, Ansible, or Kubernetes and Docker. It's a lot of work, right? To bring up a cluster and maintain it. But once it's running, properly, it's not that hard if you do it right. But at the end of the day, it's a robot, right? If Amazon Keyspaces is a robot that you paid for and it does its job, then all you really need is a handler that helps deal with the robot. So I don't think the job of the Cassandra administrator goes away. It's that the Cassandra administrator becomes more of a kind of a data engineer. Does that make sense?
Yeah, that makes sense. It's more of the shift from the infra to being a data modeling architect or something like that. Yeah.
Mm-hmm.
Yeah. Thanks for explaining, Rahul.
Sure. No, it's a great set of questions. Appreciate it. Makes for a good conversation. Any other questions, folks? All right. Well, yeah, go ahead. I thought I heard somebody. Well, we have 15 minutes that we can give back to you. I'm thinking I'm going to go take a little power nap. I was going to turn my video on after Obi presented, but my video just crapped out, or maybe it's coming back. Good to see all of you here today. Cassandra Lunch is every Wednesday at noon Eastern Standard Time. Oh, there I am. We also have a data engineers lunch every Monday. You can see all the details on Meetup, or you can, here, I'll bring it up on the website here. You can also just check out our blog or the events page there. So the next data engineers lunch is March 1st. Introduction to Airflow, sweet. And if you're interested in speaking, drop just in the chat or to direct message me your email address, and I will reach out to you and figure out where in the sequence of the backlog of topics it would make sense for you to give a presentation. It doesn't have to be something you did. It could be something that you learned and you did, just like Obi did today. The reason we want you to present is when you present stuff online and it goes out onto the interwebs, it helps you build your career. It differentiates you from regular Joe Schmo that just has a Word document as a resume, right? So when people Google your name, you're gonna be up on the Googles with YouTube listings and SlideShare listings and a blog post. So it's an excellent opportunity. When I began my career, well, I began my career a long time ago, but back in the day, in 1999, maybe 2000, we didn't have meetups. We had user groups, right? And I had just learned how to use .NET with Oracle, and I gave a presentation on it. And I think the next job I got was using .NET and Oracle. And the only reason they hired me is because I had a presentation on it. So anyways, a little bit of history showing you that I'm old, but I'm not that old. Have fun, everybody. Have a wonderful rest of the week. We'll see you guys either Monday or Wednesday. Take care.
Thank you.
Bye, folks.
Thank you. Bye-bye.
Thank you.